Hello, in this video let's discuss yesterday's third four questions of the contest. You are given an integer array nums of size n and a positive integer k. An array capped by value x is obtained by replacing every element v of I with minimum of v of I and x. For each integer x from 1 to n, determine whether it is possible to choose a subsequence from the array capped by x such that the sum of the chosen elements is exactly k. Return a zero-indexed boolean array answer of size n where answer of I is true if it is possible when using x is equal to I plus 1 and false otherwise. Constraints are n is up to 4000 and the values are up to n and the k is up to 4000. So the question is saying that given an array of size n and the value k, in first operation we try to replace the whole array with minimum of the present value we are at, which is 1 because we are starting from 1, and then each v of I. So for 1, all the elements finally will be less than or equal to 1. So for the first operation, when we are choosing 1, minimum of 1 and 4 is 1, minimum of 1 and 3 is 1, and so on. So this is the new array formed for the first operation. So after making the new array, we have to find whether there is a subsequence of sum phi or not. So is there a subsequence of sum phi? No, because the maximum sum is 4. So the answer for this is false. And then let's go for second one. So coming for second one, choose the first array itself, not the array which we got after the first operation. So try to do the operation same here. So minimum of 2 and each value will be the new array. Even in this, there is no subsequence of length phi, of sum phi, and so on. So in this way, by forming the new array, we have to find whether there is a subsequence of sum phi or not. How can I do this? So coming to brute force. So firstly, what we can think. The first very simple thing is we have n possibilities, n operations we have. So start from 1 to n. So firstly go through n, go through 1, and then find, so go through the array and replace the whole array with the minimum of that value and 1. So after that we will get a new array where we have to find whether there is a subsequence of some k or not. So after getting this, then find a way to get whether there is a subsequence of some k or not. So this is the brute force. What will be the time complexity? So this will be n. So this is time complexity where we have to traverse from 1 to n to find the answer for each value of k, for each value of I. So the first simple loop will be of n, and then we have to traverse the whole array and we have to get the new value for each index by replacing with the minimum value of that and the present number we are at. That will be extra of n. So it will be of n, and then let's say we got some other way to find whether there is subsequence of some k or not. So in the least cost possible, the answer will be at least n cube, because this is n, this is also n, and this obviously will be n, because without traversing the whole array, how can we find whether there is a subsequence with some k or not? So at least O of n is required for that also. So in this way, the minimum time complexity is n cube for sure. It will be greater than n cube, but the least thing which we can think now is at least n cube. So we have to reduce this because n is up to 4000. So n cube will be crossing 1 in n, which is not possible. So we have to reduce some n or some other thing. So what are the three things which are increasing time complexity? The first one is to find answer for all 1 to n. So can we skip this? Obviously no, because we have to return the boolean vector of size n where v of I represents the answer for ith value. So we cannot skip this. We have to find for all the values from 1 to n. So we cannot skip this. So can't be skipped. And coming to second one. So what is the second one? The second one is traversing the whole array to replace the value with the new value. So this is the second n. So can this be optimized? Let's check now. So if we clearly observe, the first thing is there is no difference even by sorting the first array. Because even if the array is 2, 3, 4, 4, or even the array is 4, 2, 3, 4, is there any difference? No. Because the only thing that matters is sum. So if there is subsequence of some k in the sorted array, there will be subsequence in the unsorted array also. So if there is no harm by sorting the given array, it is always better to sort so that it can be used in some other way. So now there is no difficulty in sorting the one, because the only thing we want is subsequence of some k. If it is there in the unsorted, it will be there in sorted as well. If there is not sorted if there is not there in unsorted, it will not be there in the sorted also. So firstly sort the array. So now after sorting, the new array is 2, 3, 4, 4 and k is 5. So let's try to come operation wise and then think and let's observe what is happening. So for first one, finally what will be the array? It will be all ones because it's the least value. So minimum of 1 and any other value is also 1. And now coming to 3, let's assume that we came to 3. So after coming to 3, what will be the new array? It will be 2, 3, 3, 3 because all these elements are greater than 3. So the new value will be 3 because we have to take minimum of 3 and the values. So minimum of 3 and the values which are greater than 3 is 3 itself. So all these will become 3 and the only number which is less than 3 is 2. So 2 will remain 2 itself. So from this what we can observe, if we try to observe, for example, let's say we have a big array and this is all these values are greater than 3. For example, we are at operation 3. So these all are less than 3 and these all are greater than or equal to 3. So after the operation, after the capping, what will be the new array? The new array will be simply all the numbers which are less than 3 will be less than 3 itself, and all the numbers which are greater than or equal to 3 now will become 3 because we are making minimum of 3 and the value which is greater than or equal to 3, which will be 3. So now if we try to observe what is happening, the whole array is broken into two parts. The first one where all elements are less than the value which is greater than the present value which we are at, which is 3, and then the second part will be simply some number of 3's, maybe 0 or 1 or 2 or any, but it will be simply some number of 3's, and the first one which is simply some values which are less than 3. So this is the new array that is being formed. There will be no number which is greater than 3, all will be less than or equal to 3, and in simply we can say that less than 3 and equal to 3. So after the operation, how the array is going to be formed? How the array is formed? Some values less than x, we are it, and then few values of x. So this is the new array form. But why is that helpful? Let's say we are at this one. Let's say we are doing operation for 1. So for 1, what will be the new array? It will be simply this array, and let's assume these are all the values which are greater than 1. So this will be capped to 1. So this will be the new one, and all these are 1. So this is the new array. And then let's make operation for 2. Let's perform the operation for 2. If we are doing for 2, all these are already less than 1, so they will be less than for 2 also. So these all will be there, but new type of values will be formed. What are those? Let's say we have these which are equal to 2. So if they are equal to 2, let's say we have 2, right? So some of these values which are now will become less than 2 because greater than the before value now can become less than or equal to 2. So now there will be new range of values where it is less than 2 because as the numbers increase, the part where it is less than or equal to 2 will increase. So for less than or equal to 3, the subarray will increase because as we are increasing the value, there will be more values. So the first one will be increasing. And for less than or equal to 4, there will be new values where all these are equal to 4. So in that way, as this is the answer for array when we are doing operation for 1. When we are doing for 2, this will be the new array and this will be the new part. For 3, this will be the new one and this will be the new one. So in this way, there is some part of the array which is not being transformed because it is already transformed. So there is no way to traverse the whole array and then replace the all values. It is just enough to make the operation for few indices. What are those indices? So let's say we are at this. So let's say we are at this, and this is the new array from this one. So these all are less than 1, and these are less than or equal to 1, and now these are less than 2. Now these are less than or equal to 2. So what are the new indices that we have to traverse to make operation from this and this? It is simply the values from this and this, because these are the only values that are changed from here to here, because these all are already less than 1, even now they are less than 2. So this is the only range of array where we have to perform an extra operation, like we have to perform some other traversal to find whether there is any update in the answer. Let's say let's check that after. So for now what we got, there is no need to traverse whole of n for whole the array. It is just enough to travel few indices of the array to pre-process the whole answer. Now let's come to next part. So let's say we got some range L to R, which is, so let's say this is the array where all these operations, all these numbers are 1. This means that all are greater than or equal to 1. So when capping the operation, all these will become 1. So what are the new number of ones that we have? All numbers from R to n minus 1 are 1, because they will be capped to 1. So now given some k, so we want whether sum is k or not, whether there is any subsequence with some k or not. So k can be split into two types. What are the two? The sum can be some part of the array which is in the range L to R minus 1, and there can be some sum from where we are getting the answer from R to n minus 1. So let's say we have 2, 2, 3, 3, 4. Let's say this is the operation, this is the new array after capping. Let's assume that the capping value is 4. So let's say we want the value 9. So let's say we have k is equal to 11. So if we have 11, this is the part 1 where all values are less than 4. This is the part which is 4. So how 11 can be found? So 11 can be found by selecting 4 from this and then 2, 2, 3 from this. So 11 can be split into two parts, where 7 is the sum from the elements which are less than or equal to 4, and then some 4s which are there. So by these two we are able to get the answer. So sum can be split into two types. The first one is some value with elements L to R plus sum because of few ones. And what is the maximum value which can be obtained from only ones? It will be simply the total number of ones. And what is the total number of ones? It will be n minus 1. So all are these one, all these are one side. And what is the count? It will be n minus 1 minus r plus 1. It will be n minus r. So there are n minus r number of ones. So we can select 0 number of ones. We can select 1 number of 1. We can select 2 ones. We can select n minus r ones also. So these are the maximum number of ones that we can select. So now we got this fixed value. So based on the number of ones we select, we can get this value as well, because this is k. This value we already got. So now what is the simple subproblem we want? Now we want whether is there a subsequence of some k minus 1 or k minus 2 or k minus 3 or k minus n minus r between the range L and R minus 1. So before what we want whether there is some k in the range 0 to n minus 1. Now we got a way to find whether there is some value of k minus something in the range L to R minus 1. And we also observed that as you are doing more operations, L to R, the L is fixed, only the R is increased by somehow. So how to find that also? So now we got a simple way. Now what we want? Now we want a simple way to find whether there is a subsequence in the range L to R minus 1 with some 16, with some k. How can you do that? That is simple DP. So function of 0 and 16. So function of 0 and k, this is the recursion we want. Why this is the one we want? Let's say if this is true. If this is true, what does this mean? It means that there is some subsequence starting from index 0. This is not exclusively including 0, but it's just the way to say that there is some subsequence in this range with some k. If this is false, it means that there is no subsequence with some k from the array starting from 0 index. So now let's start from 0th index. So if we are at 1, there are two possibilities. We can select this, we cannot select this. If we will select this, then what will be the new sum we want? If we are selecting this, the new sum will be k minus 1, which is 15. So we already added 1 to the answer. What is the new sum we want? We want 15. So it will be function of 1, 15, because we are moving to next index. And if we don't select this, then what will be answer? It will be function of 1, 16. because we did not select one. So the new sum we want is also 16 because we did not reduce by any number. So if either any of these are true, so for example, if function of 1 and 15 is true, if this is true, then function of 0 comma 16 is also true because we reached this from function of 0 comma 16 by including 0, by including the element at 0. So if either of this is true, then we will return true. But what is the time complexity of this? It will be O of n into k. Why? Because for every n, because we are traversing from 1 to n, for every 1 to n, we have to find whether there is some with k. So by using dp, we want dp of n and k because we have to store these both to memorize this. But now the time complexity will be n square into k, which is approximately equal to n cube as well because n and k are less than or equal to 4000. But this is not possible because we cannot maintain dp of n and k with some extra other loop. So how can we reduce this further? Let's check more observation. So this is the first operation where we are doing. So what will be the new L and R? It will be simply this range. This is the R. So this will be simply L and R where all these values are 1. And now after doing second operation, all these are same itself. And now few indexes from L to R which are above in the right half came to left half now. So this is the new part of the first array, and then these are all the values are 2. And now after doing third operation, all these values are same as before. This is the new range which is added to the left part, which is equal to 3, which is equal to 2. And then these all values are equal to 3. So now what we got? Now what we got is, if we try to do operation for first L to R, we'll find some answer. And then for second one, we no need to traverse all these again. It is just enough to traverse through only L and R of this, because this is already processed. By adding new L to R, we can incorporate this in the whole DP array. So from this what we got? So it is indirectly like we are only traversing the whole array once. So this is L to R first, and then this is L to R, and then this is L to R. So after all the operations, what is the whole array that we traverse to find the answer? It is simply only once, which is L to R of the whole array. But that is just simply split into number of different types. So from this we got that time complexity will be O of n, and also there is no need to maintain a global DP. It is just enough to maintain a DP of sum, DP of value, local DP or global DP, so that DP of sum, so DP of sum says whether there is a subsequence possible with some sum from the range L to R. So initially when we are doing operation, what this will say? This will say whether there is a subsequence of sum possible from this L to R. So only from this L to R. And now we will make the operations change and then coming to next one. So coming to next one, this is the new L to R. So we got new L to R. We will try to incorporate this in the old L to R, and then this will be updated. New DP of sum will be updated. What this will say? This will say what is there any possibility to get a subsequence from this L to this R, which is a broader range of the array. So in this way we can try to make a global DP, and also we can simply observe that by using L to R, it is not traversing the whole array, but it is simply traversing the whole array once, but by splitting into separate parts. So now how can we find? So let's take an example. Let's say we are at 1 to 2, and the sum which is required is 10. So now we have two choices. What are two? Like we have two different parts. The first one is get some values which are in this range and get some values which are in this range. By using these both, we have to find whether there is subsequence or not. So how can you do that? Let's assume that we are at index P. So we are at index P and we are doing the operation. So how can we find the answer? So let's check we are at P. So if we are at P, so how to get some k? By using the index at value P, how to get some k? If there is k minus Vp already existing, then k will be also existing, because by adding this, V of P can be skipped. So if k minus V of P is already getting formed, then k also will be formed, because V of P is the new value that we are able to get because of this. So this will be cancelled and new k will be found. And also, by, let's say we are at new index. When we are at new index, there are two things that need to be checked. The first one is whether we can find a subsequence with this sum, and also what are the new sums that are possible when we include I. The only thing is we don't want only the answer, we also want the correct global DP so that it will be reflected correctly for the next array also, for the next range also. So the other thing which we have to note is there should be a possibility that we have to get the correct DP array. So given we are at index I, we have to update the DP also, where by including this, what are the new sums that are possible, right? So hope you got this. Let's check the code for better clarity, and then before let's discuss this. So let's say we are at, so what is the least value which may be newly formed by selecting the value when we are at index I? That is simply v of I. So let's assume that we are at 1, 2, 3, 9. So let's assume we completed all of these, and this is the index we are at. So if we are at this, is 9 already possible by any subsequence before this? Obviously no. The maximum sum which we can get is 6. So we already got 6, but because of 9 we are able to get DP of 9 also. So now we have to make DP of 9 true, right? So that now it is correct. So that now we are able to correctly update DP. So hope you got this. Because of the new 9, we are able to get a new DP as true, which is DP of 9. And also, this is not true till before, because there is no subsequence of sum 9 till here. So when we are reaching 9, what is the least new value that we are able to get? It is simply 9, because this is the least value that we are able to get newly because of this. So DP of 9 true. And what is the maximum value that we can get because of 9? That is 9 plus 1 plus 2 plus 3, because there is no sum 9 plus 1 plus 2 plus 3 till now. So this is the new value that need to be updated. So we have to make DP of 10 as true, DP of 11 as true, and so on till DP of 16 as true, because these are the all new DP values which are able to get a subsequence of this sum by including 9. So we should update all these to true. But the only maximum value we want is k. Let's assume k is 11. So if the k is 11, is there a way to update DP of 13 to true? No, because we only want till DP of 11. So we will just cap this also. So we will traverse from v of j, v of I till value of k. And then we will update all of these to true. So what is this? This is indirectly minimum of k and v of j plus maximum sum. But we don't need the highest value, we only want till k. So simply update v of j till k as 1. So that these are the new values that are 1 because of the new value v of j. These may be existing in the array as 1, but we have to update this because cases like this. So for 1, 2, 3, 9, there is no 9 before. So we must update 9 to 1. So hope you got that. So now we process L to R minus 1. So now we process L to R minus 1. So what is that? So we got to the new array, we got to the new index, and we updated the global DP. So we traverse this also, we update the global DP. So after traversing this, what will be the new DP? The new DP will say that, for example, let's say we are at 14. So if DP of 14 is 1, it means that there is subsequence of sum in L to R minus 1 with sum 14. So now we forgot one thing. What is that thing? So we got other range also, which is R n minus 1. So which is simply static values which are equal to I, which are traversing. So now we will traverse through number of i's we selected. Let's assume we are selecting 0 i's. So if we select 0 I, what is the sum we want extra sum? It is simply k, because we are not selecting I. If we select 1 I, what is the new sum we want? It is k minus I. So if k minus I is in this range, so how can I check? If DP of k minus I is 1, it means that it is already there in this one. So if this is there in this, we can select any of 1. So then we can get the answer. So if we select 1i, if there is k minus 1 sum in DP of I, L to R minus 1, then there will be answer. If we select 2, then what? Then if there is k minus 2i in the DP as true, then we can get this also. If DP of k minus 2i is true, then we can select 2i's and we can get sum of k, and similarly all. So in this way, we will first update the correct DP by traversing L to R minus 1, and then we will traverse from R to N minus 1, and we will check 0, I is to be selected, and we'll check 1i to be selected, and so on. And if any of middle I is true, then we'll return. So let's check the code. So firstly, we'll input the value and then we'll sort, because there is no harm in sorting, so simply sort. And then initialize dp of 0, like dp is the dp of sum indicates whether it is true or not, with subsequence getting sum as k or not. So initially all are 0 and dp of 0 is equal to 1. Why? Because by taking empty subset, the sum is 1. So dp of 0 is equal to 1. And then make boolean of answer as n. And now start traversing. So I is equal to 0 to n. So now we are doing the first operation. So we have to get the new dp, we have to get new L and R. So where is that one? So now L and R will be updated for every value. For every value, the new L and R will be found. Right? Hope you understood that. Yeah, this is the one. So initially L is 0. So we'll start from this. So we'll go until all values are less than or equal to 1. Right? Because this is the part of L and R for the first operation itself. So we'll traverse till all values are less than or equal to 1. So let's assume that we came here. So when we came here, it is greater than 1. So we'll break the loop. So if we break the loop, this is the new L for the next one. Right? So this is the, so let's check the code also. So initially index is 0 because L is equal to 0 for the initial operation. And now L is equal to index. Why? Because index is the highest index that we are able to get after for the before operation. Let's say we are at L and R. And now this is the first operation. For first operation, what is the criteria? All of these should be less than 1 and these should be greater than 1. So greater than equal to 1. So now we will start traversing the array till we find all the values which are less than or equal to I. And now when we reach the first value which is greater than I, we will break, because these are already processed. For the next operation, this will be the new one, this will be the new L, and then we will traverse again till all the values are greater than 2, and then we will get the new R. This will be the new for the second then, and then we will start from this for the third operation and so on. So initially L is equal to index, and then we will start traversing the array till we find a value which is greater than I. So while index is less than n and v of index is less than or equal to I. So till this is correct, we are able to add all is in the left half, which is less than or equal to I. So till less than or equal to I, then till increment the index. So when we came out of this, what it means? It means that we reached index greater than n, or we reached the index where v of index is greater than n. So this should not be a part of left, it should be part of right. So that's why we broke the loop. And then now what will be the answer of I? So answer of I is simply function of I plus 1 L and R. So index is equal to R minus 1. So we check that in the code also. So this is the new R. So this is the R we got because we broke the loop. And what is this? It will be R minus 1. So now we are doing operation for L to R minus 1. And what is I plus 1? So this is 1 based indexing, because for the first operation, the answer of 0 indicates for the first operation. But we have to update with respect to value 1. So I plus 1 is the value that we are capping. Answer of I is the answer where we have to update based on 0 based indexing. So L and index is L and R minus 1. So this is the new value. And then what are the number of ones we have? It is simply from R to n minus 1. It is n minus R. So it is v of v dot size minus R. This is the number of i's we have. So which is what is I? It is simply value. So that we are able to pass in the parameter. So what does this mean that? So this means that there are count number of values. So we will start from 0 till count, so that we will check whether if we select this, is there already some with k minus I into L already from L to R minus 1? If there is there, we will simply return 1. So count is equal to v dot size minus R and then L to R, and then start through traversing through the loop, and then j is equal to k. So we discussed that because of the new index I, we are able to get these values. What are this? It is simply from v of I to k, right? Because v of I is the least highest value that we are able to get, and k is the highest value we want, because greater than k we don't need to update the answer. So if there is j minus v of I, so make dp of j as 1. So what is this doing? So so this is simple, right? So if there is some j minus v of I, Then by adding v of I, we are able to get j. This means that we are incorporating v of I in the global dp, right? Because without v of I, there is already dp of j minus v of I. So by including new v of I, we are able to get dp of j as true. So we are updating global dp. So in this way, we will traverse the whole loop, and then we will make the decision. So we will start from I is equal to 0 and I is less than or equal to count. So if we select I number of values, we want k minus I into value. So if this is greater than or equal to, and if dp of this is true, it means that by selecting this, we can get this subsequence in the range L to R minus 1. So if this is true, then simply return true. Else return 0. In this way, we can find the answer. So hope you got this. If you have no doubts, comment below. Let's check the next one. So you are given integer enums. A subsequence is stable if it does not contain any 3 consecutive elements with the same parity. Return the number of stable subsequences. So n is up to 185 and the values are also up to 185. So the question is saying that we have to return the number of subsequences such that no 3 adjacent values in the subsequence should have same parity. Let's assume, let's say we have 1, 3, 5, 6. Is this a stable subsequence? No, because all these 3 are odd and all these 3 are consecutive. So this should not be a case. So this is not a good subsequence. So in this way, we have to return the number of good subsequences. So let's simplify. Let's say the only condition is no 2 adjacent should have same parity. So the question is saying that we should not have any 3 consecutive. Let's say we are discussing about 2. So odd and even is correct, but odd is not correct. So now this is very simple. Let's say we are at index I. We are at index I and the present value which we are at is odd. So if this is odd, then when can we consider in this subsequence? So when can we add this as a part of subsequence? So we can add this only if the last one is not odd. If the last one is even, only then we can add. Because the question is saying that we should not have OO, we should not have EE, because no 2 adjacent can have same value. So if we are at odd, then when can we include this in subsequence? We can add this only if the last value is even, is odd. Sorry, if this is even, only then we can add. So how can we make sure that the last one is odd? So simply we can add that as a parameter. So function of index comma previous parity indicates the number of subsequences starting from index I, and the last parity is the previous parity parameter. So let's assume that function of 3 comma 0. So function of 3 comma indicates that what are the number of good subsequences starting from index 3. Starting from index 3 and the last one is odd. So the last one is even. So if this is even, then we can make a condition based on the previous parity which we already have. So now this is very simple. So we can simply use function of index comma previous parity to track whether the last one is same as before or not. So if the last one is E, if this is O, only then we will include this in subsequence. If this is E, then we will not include. Then we will simply continue to the next index. So we got the solution for 2, but the question is 3. So there can be OO also, but there should not be OOE. So how can we make sure of this? Now this is very simple. This is extension to before one. dp of index previous one previous 2. So for before 2, we only want the before one, but now we want before 2. So how can we make sure? So if this is V, so this is the previous parity 1, this is previous parity 2. So now we got this, and now when we are at index I, how can we check? So how can we check here? If this is not equal to I1, if this is not equal to this, and this not equal to this, then we can include, and then we can find the answer. But this may be slightly error prone and over competitive, but simple. So but let's try to make it generalized as well. But what if the question says we have to return for 4? So what if the question says that return the number of subsequences so that no more than 4 should have same? We can't take other dp parameter, right? It will be very lengthy. dp of previous 3, this is very bad and very lengthy also. So let's try to make more generalized. So only by 1 parameter or 2 parameters, let's make sure we are able to make both this one and the new one correct as well. So now what we want. So let's say, like the before one, we only want to track the previous one. Let's check whether that is possible or not. So let's say we are at a value which is odd or even. So let's assume the before one is odd. So if function of index comma odd is enough to find the answer, it should be enough for the whole answer as well. But that is not the case, because we also want the previous index also, right? Because we have to make sure that these three should not be equal. So we don't, but we want previous value also. So how can we make sure that we are adding this? So if we clearly observe, from this, let's say we are only storing last parity, EO, OO and O. So this is the new index we are at. So we are only storing last parity. So let's say we are considering this one. So if we are considering this one, we are adding E. So we are adding E to the present subsequence. So is this a varied subsequence? Obviously yes. Why? Because we don't need this. This is odd, this is even. So there is no subsequence, there are no three adjacent values where all these are equal, because these two are not equal. So why we are caring about the previous one? If these both are equal, then we have to take care of before. If this is O, this is not possible. If this is E, this is possible. But directly, the previous one is itself is not same. So why we are taking care of this one? We don't want this. So here, there is no need of the previous parameter. Okay, now let's check the other case also. So now we are at odd. So if the previous one is odd, now the before one is required. So if this is odd, if this is even, then we can select. If this is odd, then we don't need to select. So for one case, there is no need to get the previous one. But for one case, there is a need to get previous one. So how can we get which one we are thinking about? If we clearly observe more, what can we think? So this is triple O. So triple O is one case we are thinking about, and EOO is the other case we are thinking about, and don't care, OE is the other case we are thinking about, right? So what is the thing we exactly want? The only thing we want is what is the length of the subsequence ending at the present index such that all three are the same, all the two are the same. That is the only want, right? So let's say, what is this? All these three are same. So the only problem we encounter is when all these three are same, right? So for example, the only thing we want is what is the length of consecutive numbers with same parity till the last index, so that there is no need of last parity again. So till now what we discussed? So we discussed that we want dp of index and dp of previous one and previous two. And why we moved from that approach? That may be error prone, and also we are trying to generalize for length 4 or 5 or many, so that there is no need to maintain a huge GP vector of that much dimension. So now what we've got? So let's say we are coming from this. So what do we want? So the thing we want, we want index for sure, and also we want the last parity, which is odd. So with this, what if we try to maintain other parameter length? So what is this length? The length is very simply what is the consecutive length of the numbers in subsequences same parity. For example, if the length is 1. So if the length is 1, it means that we are this index. So this is the last one. This is the last parity. So if the parameter we are passing with length as 1, it means that this is the only number with odd parity. So what does this mean? It means that the previous one is even, so that it is not included. But what if, let's say, we are at OOO and this is odd, so we are passing 1 to here, and now the length is 1. So the length, the parameter is 1, and now the present value is also odd. So can we consider this? We can consider. Why? Because the maximum length till now is 1. So this is the only length 1. So the question is saying that we should not have 3, but we can have 2. So we have this as odd. So we can simply add this here, so that the length will become 2 for the next one, because we got 2 elements consecutively with the same parity, which is odd. So that now we are at odd. So now let's say we are at odd. So we are at odd, and the length is 2. So what will be the parameter for this? It will be simply function of index comma odd comma 2. So this is what we will get. So now we will check based on these both whether we can select this or not. So firstly, these both are same parity, right? And then can we include this with this? No. Why? Because the length is already 2. So if the length is already 2, if we're adding the same parity again, What does this mean? It means that we are making length 3, which is not good, which is not correct. So we cannot include this. So simply continue. So from this what we got? So by simply making another parameter for the length, we can incorporate any lengths here based on 3 or 4 or 5, right? So now we got. So it is simply the function of index comma length comma parity of last. Why parity of last? Let's say we are only maintaining length. So the length is 3, the length is 2. What does it mean? It means that both are same parity. But what is that parity? So that only then we can include this in the subsequence. Else how can we include? So with the length also we have to make sure that we have to pass which parity is also there with the same length. So that based on that we can select the present subsequence is selected or not. So what is the space complexity and time complexity? The index is n, the length is 2. Why 2? Because we will not store length as 3 anyway. Because when we are reaching as length 2, we will not include this. So length cannot be 3 anyway. If the length is 2, this is the highest value possible. We will not add a new element. So this cannot be 3 anyway. And what is the parity of first? It is simply odd or even, which is 0 or 1. So in this way, now we are able to get the DP. Now let's check the transitions. This is very, very simple. So before coming to this, let's say initially function of index 0 and length 0, and what is the initial parity? That can be odd or even. So simply pass 2 so that it will check for both 0 and 1. So initially parity is 2. So now let's check the code. So initially we are at this one. So if the last parity is 2, so what does this mean? It means that we did not start any subsequence till now. So that only then the parity is 2, else the parity would have been 0 and 1. So if the parity is 2, it means that we are starting a new subsequence from this one. So we are starting new subsequence with this. Now what will be the length? The length is 1 because it's a new number in the subsequence. So the length is also 1. And what are the new subsequences? When we include this, it will be simply function of I plus 1 and the length is 1 because we are including. And then what is the parity of this block? It is simply v of I mod 2 because it's the new parity. If this is odd, there is a length 1 with odd parity. If this is even, there is one length with even. So function of I comma v of I mod 2. So there is the new subsequences if the parity is 2. If the parity is not 2, it means that we already started taking subsequences. And then how to check? So the next case is, let's say we are at OO and we are at E, and we are at OO and we are at 2. So we have to check whether this parity is equal to last parity with the length as equal, right? So what we have to check? If the parity of the present number is the parity of last one, only then we have to check. For example, we are at O, we are at T and the last value is O. So if there is a case, is there a way to check the previous one? No, because this is directly not equal to the previous one. So we are making a new length with 1 because the new value, because this is not the same one, because we discussed that the length is the length with the same parity. But here, till now it is O and now this is E. We are making the new block. So the new length will be 1. This is neglected because E is the new block with length 1. So you have to check whether the present parity is equal to previous parity or not. So if this is the previous parity, this means that this is equal to previous parity. So now we have to check whether the length is less than 2. Why? Let's say we have OO and O. So only then the length. So these both parities are equal. So this means that both are O. And the length is also 2. Because in the previous subsequence we already have these both. So now can we add this? No. Because if we add this, the length will be 3, which is not good. So we can include this in the subsequence only if the length is less than 2. Right? If there is only O, then we can add. Or if there is no O, then we can add. But if we have 2 O's, then we cannot add. Because we'll get length 3. So if the length is less than 2, only then we can incorporate. So if the length is less than 2, then what is the new answer? It will be simply function of I plus 1 and length plus 1. Why length plus 1? Because before are odd. Now we are also adding odd. So the length will be increased. Right? Before also odd. And now we are adding odd. So simply increase the length. So function of I plus 1 and length plus 1. And what is the parity of this new length? It will be O. Because we are simply adding the old one. Because these both are equal. So the whole will be also this one. So function of this one. So this is the answer when we get the parity. But what if the length is greater than 2? If the length is greater than 2, then we cannot add. So this is simply 0. So we are not doing anything. And now what if the parity is not equal to the previous one? So what if the before one is odd and the present one is odd? Before one is even and the present one is odd. Then what? Then we are making a new length one because the new block. So now function of I plus 1 and 1 because we are making a new length. And what is v of I mod 2? It is simply parity of this one, which is the parity of last block we are considering. So in this way we can find the answer. So simply mem set dp because we are initializing -1 and then function of 0, 0, 2. 0 is the index, 0 is the length and 2 is the initial parity. So if I is greater than or equal to n, it means that return 1 because we reached the end, so return 1 and check whether this is already computed. If it is already found, return that value itself. Else first find the answer by excluding this. So simply function of I plus 1 length come out. So we are not changing anything, we are simply ignoring this in subsequence. And what the next three conditions we already discussed. So if it is 2, if it is equal to last one, else what? And simply return this by storing in dp of I less than 2. So in this way we can simply return the answer. Let's check space optimization also. So this is also simple. Why? Because this is standard. So at index I, we are only considered about vectors and index I plus 1. So from this, so for function of I, we are depending only on dp of I and function of I plus 1 which is dp of 1. So instead of storing whole, we can only store two vectors for I and I plus 1. So firstly convert that into iterative way. Hope you know that. So after storing in iterative way, then we can simply store only two vectors, one for next and one for current. And after finding the answer for I plus 1, we can simply update the next as current. So what we are doing, so we are coming from last. So let's say we are at I plus 1. So we are at I plus 1 and we'll update the dp of I plus 1 with respect to all, and then we complete all of this. And then when we are coming to I, what will be the next value? The next vector will be the current one, which is the vector for I plus 1. So when you are moving to the before one, for this, what will be next? The next will be this. So for this, what will be current? It will be current. So when we are coming to the previous one, next is equal to current. So that by only 2, we are able to update the answer. So let's assume we are at 3. So we got 3. We found the answer for this. And then we will update the answer for this. And then by only 2 vectors, we are able to make sure we are able to find the answer. So this is not required, but if we are concerned about the space, this can be off 12, which is off 1, which is constant. So in this way we can find the answer. If you have doubt in any of these, comment below. See you in the next video.